So I want to start calling the new functions, so I'm going to go over here to API implementation where I can get them pulled up, and I'm going to go over to let's do a real one. Let's go to sticky jumps. There's a lot of stuff in here that does a lot of hard work. So, yeah, so this is going to be hard to remember all the details that go into this because it's not straightforward at all. But we have a jump destination array and a jump source type. First jump index handle. So a jump destination array is an array in the sense that it has a marker handle and it knows the first jump index. Means that like in the source we have 100 things. If that says 12 first jump index, then the first jump index happens at 12, I guess. And then the source tells me for all 100 things the line number and the flag. So I have one destination array per buffer, and I have the sticky jump source is per jump line. Okay. And then these work as indexes into the jump line array. So there's a few of these and a bunch of these, basically. And there's a few of these because each one is an array, and if we added up all the elements of all of these arrays, we would get a count equal to this. That's the idea. Now, when let's see, marker list node. Yeah, so I have one marker list for each buffer that can contain a marker list, and that buffer ID there tells me which marker list which marker list this is. It basically says this buffer ID is the buffer that has the jumps in it. And then the locked jump state tells me which view I'm using for jumping, which marker list I'm using for jumping, and which index I'm at in that jump list. What I don't see is how, I guess the marker handle API has a way to find out what buffer is tied to that marker handle. Marker handle. Yeah, get buffer by marker handle. Okay, so when I add markers, I allocate a certain number of markers here. Oh, I set a delete callback and everything. Really? That's fairly intricate and not really commensurate with the new API in a great way. Although I was always expecting to have to change this API, I guess, so that's not too surprising. I just didn't realize how far this had already gone. Buffer add markers, and then buffer set markers. Where is that? Why don't I have a C also for that? So add get buffer, get user data, set markers. Okay, so this API is a little bit borked. Let's take a look at buffer add markers. So here I'm calling it in jump sticky, and I'm calling it again down here. This is a duplication of the same code twice, because why not, right? I would kind of like to actually remove that problem if I could. That problem exists because here we're in a loop and we emit something when we know we're going to a new buffer. That's when we emit one. And then at the end, we emit another one. But they're identical in terms of what they actually have to do. So I either should have written a wrapper function, or I should have gotten that code path to trigger by, again, on the last iteration no matter what. Now maybe that's not an easy thing to do. Yeah, it's not easy to tell when I'm on the last iteration, I guess. So if I can't read a line, why do I need to read line string? Line string is no longer used, but what is getting used is sub error location. Output parse jump location. Output jump. I see. It's fairly complicated how we decide when to emit. It has to do with, first we just look at, did we want to output a jump, but then we look at the location that we're jumping to, and yeah. So I feel like I could probably clean that up, but the risk of adding a bug in the process is pretty high. And testing this is pretty darn hard. Like, it's not very easy for me to come up with gradual test steps and test along the way, because testing along the way is going to be very unlikely to actually catch mistakes as I'm doing that. I wish I could reduce the complexity of this though, so that I could be less scared of touching it in the future. Either way, point is, once I've figured out how to deduplicate this to make it easier to deal with the code, the handles get allocated, the marker handle gets allocated on that buffer there, and then there must be something I do in terms of a hook. Buffer add markers. Yeah, right here, sticky jump markers cleanup. And what that does is it marker list remove reference. I just iterate through all the destinations and take out those handles so that they're empty. So what I don't get is, do I really need... It feels like I don't really need anything too fancy to use the new API to make this work, but it's a little bit hard because the code is so complicated to even know for sure that I'm not missing something. I think I could get away with actually removing this completely, because what this does is it creates it gets stored in an array, and when I'm iterating through these, I use the elements of this array to find the markers, and the markers are attached to this handle here. And I use this to figure out which destination I'm on. If I just moved over here this and eliminated that completely, I would actually have enough information to always get what I need. And when a buffer dies, what would happen? Well, the markers would disappear. We're trying to go to the buffer ID let me close my eyes and imagine how I would build this thing from scratch and see if it's very complicated, because trying to figure out how to work backwards from this one is just so weird, because the thing I'm trying to move it to is so different that it's not clear in my head anymore what I would even do to build the system. So I want to first imagine how I would build the system using the new API that I've just provided. I would have basically the way this is structured is I want to be able to at any given time say reparse this thing and put jumps on it. When I do that, first thing I do is I clear off any jumps that it currently has associated to anything. So if it had jumps that pointed out to other buffers, those are gone. So basically I end the buffer, which should shut down all of its current attachments, and then I use the same buffer again, which I've only ended but not closed. So I guess when I end the buffer, that needs to clear out the keys and then create a new dynamic variable block from scratch whenever we end the buffer, I guess. Yeah, I'll have to track that down. Okay, so going forward, I need I have in my head now a buffer with text in it, and I'm going to parse it. It has no attachments yet, and then I find an error line. And what I want to start doing is every time I find an error line, I mark where in the buffer I think that the jump that I think that takes me, which buffer it takes me to, and the location it takes me to. And I start storing an array of all of those jump positions until I'm done accruing jump positions for a single buffer, at which time I create a new marker handle on the destination buffer with those positions, and I stick that marker handle under the scope that is the intersection between that buffer and the jump list. And I say store that under a variable called the jumps or whatever. And maybe, okay, so one thing that will come up is that I may need for any given buffer there might be two batches of things. So really what I'm doing here is I'm finding the first file and going, okay, there's an error. Let me find all of the jump lines that go to that buffer and parse them out, and then do it all at once. Put all of its markers in one marker handle. Then well, if I just had to return to me the whole list, the whole darn list of here's the buffer, here's the jump position for everything in here, then the rest of this wouldn't become much easier. I do the parse and get the parse data, and then from there I separate that process of parsing it from the process of sticking markers everywhere. Yes, that's the design I should have gone with in the first place. Okay, once I have that part separated out, what's the next thing I need to do? I need to create a marker handle for each buffer that shows up there. So all of those things that I have in that array that are spit out will want to know the buffer that they go to, the line that they go to in that buffer, and the line that they come from in the jump buffer, like in the jump list. And then I can sort them by buffers. Instead of keeping them, they'll originally probably be sorted by their line number in the jump list, but I'm going to resort them so that all the buffers of the same ID are grouped together. And so all of the jumps into buffer 25, for instance, will be in one batch, and then I can stick that into a marker array attached to the buffer and to the jump list. Okay. Okay, so then when I'm stepping through on my jump list, I have an array that says for each element in this array, here's the buffer ID, here's the index into that buffer ID's marker array that we care about, and here are the flags. Okay, that's pretty straightforward. If at any time one of those buffers disappears, then the handle, then that like intersected dynamic scope goes away, so the marker handles are automatically cleared out, and the spots that I have in the array just stop responding when I try to use them, because when I go to them now, it says here's the buffer ID. I try to put in the pair of buffers, and what I get back doesn't come up with anything that I can use. So the variable is gone, and we can't jump to it anymore. And that's right, because the buffer can't even be queried anyway. But I feel like I would be more comfortable with it if I could somehow mark those slots as dead anyway, because who's to say there won't be a new buffer that comes along with the same ID later that then responds and returns a dynamic scope, and then that dynamic scope might still be missing the variable, but it is just starting to get a little weird, because now what I stored was this array on the list, on the lister buffer, and that, okay, I see. So there's kind of an issue here of I want a centralized way to iterate the jumps, and I want that list of jumps to dynamically change, so that, for instance, maybe what I need is the ability to say I'm creating a linked list, and whenever something from this linked list, whatever, like each of these nodes might be in a different dynamic scope. And so when one of the nodes in the dynamic scope is freed, I don't just want the memory freed, I want the list fixed up as well. That would be pretty useful. So we're talking about putting okay, and then I have the ability to say, give me a handle to this entire list somehow so that I can ask for the first member of it. How would I do that? Well, if I have a sentinel that is stored in the lifetime of the jump list itself, then I can always get that sentinel back. It'll never need more than one sentinel. It's a list that only this buffer wants to store, basically. And then all these other nodes exist in the cross-section of the lifetimes between the list buffer and the other buffer. So then this dynamically linked, or this doubly linked list can be dynamically shrunk as things get deleted off of it. And I can iterate everything that's in that list by just going, okay, go to the next node, and then that next node I I have an API that says, give me the node at this variable name. It returns it to me, and then I can say, okay, here's a node I have. Give me the next one in the list. And when I get the next one back, I can then say, okay, give me the buffer. Maybe that each node has in it a next and a previous and a user data value. And so that I can ask for the value inside the node, and that value gets me to the array for that buffer. Okay, I want to now change gears here because I think I've seen enough of it in behind my eyelids to have a pretty good idea of what I think it would be like. So let me imagine trying to actually write that out. If I try to do this without changing the API at all, then here's what we've got. We're initializing this list. We're going to have a temp memory. That's about as far as I'm willing to clone the stuff from below. Because the next thing I need is a yeah, I want an ID position jump location array. Called the jumps that I get by going jump buffer parse jumps, and for that I pass in app, the partition, and the interested buffer ID. Okay, now I have an array of jumps. Now for each of those jumps, what I want to do is I want to sort the jumps, right? So I'm going to say jump array sort by buffer. You know, I need a little bit more complicated than this. So let's go back to here and we'll call this a sticky jump array. And then jump buffer get sorted jump array, maybe. And so then I have my jumps. I can now iterate my jumps. And what do I want to do with those jumps? For each of these jumps, I need to why don't we do it this way? Jump array sort buffer first, and maybe I want to be able to put more than one node in there anyway. Like maybe I want to have these nodes not keep track of a slot so that there can just be n of them invisibly. Yeah. So I wouldn't actually sort this. Okay, so then what I would actually want is sticky jump do I have range? I think I have range. Range array buffer ranges equals sticky jump array mark buffer ranges app partition jumps. Now I have my ranges, and what do I want to do with that? I want to visit all my ranges. For each of my ranges, what I'm going to do is create, well, first I need to know the buffer ID, so I'm going to get the jumps.jumps buffer ranges.ranges I.first. So that's double indexing there. I'm going into the ith range and pulling out its first value, pulling out the value of first on that range. That is an index into this array that I then use to get my buffer ID. Then I have a buffer ID now. I want to create two things, right? First I need to get the marker handle of interest. Buffer add markers, and let me look up the API there so that I'm matching it. I'm going to pretend like these things are getting eliminated from the API. App buffer marker count. Okay, so that's going to be app buffer ID, and then the marker count will be jump count. What is jump count? Jump count is what we get when we take the range that we get here and we do end minus range start first one past last. Yeah, so that's our jump count. We add those markers there, and then we're going to set the markers. Buffer set markers. App handle first marker index, jump count, and then the actual sources of the markers. So here's where I'm going to put the markers. I'm going to need a markers array now, and we're going to want to put this under a marker temp. And so what we need to do with this part is we want to convert what we have right now, which is a range over the sticky jump array, into a set of markers. And markers have the following members. Bloop, position, and lean right. So for each of these, we're going to set the position equal to something, and the lean right equal to false. Now for the position, I want to get the jumps j plus range first dot position. And this can actually be if I go back to jumps real quick, I can actually use this like I originally thought I would, because I'm not doing the sorting thing. Okay, so I have this array of locations, and then yeah, we're going to call that a jump array, mark buffer range. We mark the buffer ranges in it, and then we're going to iterate the buffer ranges, and for each buffer range we find out the buffer ID for all the buffers in that range, we get the count of number of jumps in the range, and then we add markers to the buffer that we add markers to the buffer that go into that handle there. Now those markers currently are just allocated on that buffer, which means that if the jump list closes, that allocation stays in existence. So one thing I want to do is imagine how would I go about linking this to the scope of the intersection between this buffer ID and that buffer ID, right? So this right here is going to be the target buffer ID, and then I need to get some dynamic scopes. Buffer scope is going to be pushed out here. We are going to call buffer get dynamic scope app buffer ID, and then down here we're going to call buffer get dynamic scope. This will be target scope target buffer ID. So now I have the two scopes that I need. I can make a scope array like this with buffer scope. Why don't I actually do it this way? And then scope array 1. So now I have filled both slots of my scope array, and I can ask for the scope that I'm particularly interested in, which is the get intersected dynamic scope. We'll get that by calling it with scope array count scope array. Now I have the scope, and what I want to do is when I say buffer add markers onto that buffer ID there, I want to also say something that lets it know that I'm talking about putting it into this scope, not into the buffer's main scope. And the trick is it also needs to know the buffer ID for which this is connected, right? So I think what I actually do here interestingly, I think what I actually do is I only specify the scope from the additional thing. There's always an implicit scope when I do buffer add markers, right? I don't want to redundantly have to always put in the scope for that buffer and the buffer ID that the markers are directly attached onto. So how else would I do it? I guess I wouldn't do it any other way. It'll go like this. So we're going to do that scope, and then what I can do is say that in addition to all this, there's an optional scope parameter here that looks like that. So that it can be a 0 if it doesn't want to be used. And then buffer add markers. Here's the handle we get back. Now that handle is attached to this buffer ID, but it also is subscope to anything that was put here. So if you put a 0 here, you just get the default behavior. If you put a scope here, and that scope contains anything other than this buffer in it, then that scope and this scope get intersected, and then it lives in that scope, but it is attached to this buffer. Now that means if you store that handle, and then you go back looking for it later, you could have stored it in a way that lets you get back to it without it actually still existing. Which is where I start to wonder if instead of returning marker handles, I should be using variable IDs, managed variable IDs. But that means that you can't have, anytime you do that, you can't have an arbitrary number of like things allocated without an ID attached, and the IDs are going for more than just variables. Now I think this is the right way to do it. Okay. Now the only thing I have to double check is marker handle needs to be a void pointer. Great. Okay. So, I add the markers using that system. It's inside that scope now. And so the other thing I want to do is I want to so that's why I have to do it the other way. Okay, so that goes there, and then we get the double scoped thing there, and we call so I'm going to allocate the manage list node onto this scope. Meanwhile, I'm going to insert it that'll be the node handle. This up here can be the marker handle. So I want to insert the node onto the list sentinel, and I'll do list insert back. And then I want to do managed list node set app. Here's the node handle, and put the node handle there. Node handle, and then I want to set this to put her as int uint64t the marker handle. Handle as u64. helper.h, putter as int, define handle as u64, uint64t, putter as int a. Okay. So that lets me set the node's value to that marker handle there. And now it's sitting on the back of a list. Marker handle equals that. I'm wondering about these managed list nodes. I feel like I like it. I'm just not sure. There's a little bit of doubt in me that it's just too far, but maybe it isn't. Maybe it's a useful level at which to draw the line for the API to provide that. I mean, the alternative is that you just, whenever you allocate a thing, you can also stick onto the same scope a thing that decides what to do when you free that, and then you would manually be able to do the nodes and stuff, but that's I mean, that's something that I could implement later and re-implement this as a wrapper around it anyway. And so really that's more general, and I'm not sure that there's any benefit to going that general. In fact, it feels like a bad idea to go that far, and maybe less bad to go this far. I'm not sure. I want to try it. It feels a little bit unusual for me to do something like this. It's not my gut instinct that I would definitely like this, but I'm not able to put my finger on anything that is definitely bad about it. I guess the only thing I'm not sure about is how many uses it has outside of this one case, and if it only can be useful in this one case, why am I implementing this on a custom layer? Anything that is a one-offer type thing ought to be able to live inside the core. But markers in general don't want to live inside the core. They want to be exposed to the custom layer. They need to be known by the core so that it can manage them in terms of updating their values when edits happen on buffers. But do jump lists need to happen in the custom layer? I feel like they do, since they are above the marker level. Yeah, I think this is fine. It's just a bit, I'm not sure if I can imagine having a list node anywhere else. Maybe there would be reasons. I mean, the whole reason that there are list nodes is that I can make a list of things and assign each node in that list of value and not have to have... Okay, actually it does generalize very nicely. It's basically the same as a managed variable, except that with a managed variable you can't have an n of them because you have to define each one. So if you want to be able to have one variable that refers to a list of things, you actually need this. And then you can have the added weird benefit of craziness that a node doesn't, not every node in a list needs to be allocated in the same scope. And so you can have a list that automatically corrects to the things that still exist over time, which could actually be just a useful thing to have available all the time. Like you can make a list that's like a stack of your preferred order for buffers to appear in each view using this, actually. So I like it. I decide to like it. Actually, that's really cool. Yeah, this is a good idea. Alright, I'm excited now. Let's keep going. So, Okay, so marker handle. Buffer set markers. So here we add the markers. And we set them. We keep that marker handle around because the next thing we do is we get the intersected scope for both of these things and put a node in there. And that node I feel like it would be just slightly nicer looking if I first get the intersected scope and pass that intersected scope here. I don't know why. It's just weird because that was a little bit redundant, but it's actually not going to kill me to allow it and to prefer it this way. Right? The only thing that'll be weird is I do have to implement it as if it could work both ways. Because it needs to know this in particular, and it might want to set here, and so it's just going to have to take a set containing this element and this set and union them together to get the intersection set. So I get a node, I tie it to this scope, I insert it into this list here, and then I set it to have this value in it. And then I'll also want a node get, and that'll just be a matter of passing the node handle into that. Yeah, okay. Okay, so the thing I'm missing right now is the list sentinel, which needs to exist up here. The list sentinel can be a node that I put on this scope. And when I first initialize a node, I'll always have it point to itself. And then inserting it into something else means removing it from whatever it's in and inserting it. And there will be no such thing as remove, except if you want to insert something onto it. If you want to remove something, you can just say insert to itself, because that would have the effect of removing it from where it is and then doing the insert onto itself. So yeah, manage list node insert app AA list insert back would be the way to, or front would be the way to remove something from a list. Manage list node set sets a value on that node. Each node has a 64-bit value, plus each one takes up 3 times as much memory as it needs for its storage, but whatever. Maybe I'll improve that some way in the future. And then I think that's just it. I think that's how I init the marker list. And that's way simpler than all of this, although part of what makes this simpler is that I've simplified the parsing stuff. if I start with those two things, I can probably make this look very simple too. So that's what I'm going to do next. So there's some API usage code. I might not get to actually run anything today and start testing for a little while. We'll find out, I guess. Because the first thing I want to do is get those helpers that I need up and running. And so, let's try, well, I don't know, maybe I don't want to bother screwing around getting baby steps there, because it's going to take such a long time. I don't know. Let's do an intermediate version. So here's the final version. Now all of this is going to be different, with the exception of this part that'll be basically the same. And this part, I guess. So that's the same, this is all gone. Okay. So let's see here. Location buffer, target buffer ID. If it exists, I look at list dest count versus write. So I need to get some of this nonsense going up here. And that's all after the temp. So let's do that part. We can get rid of this. We can get rid of this. Okay, so I will do the allocation there. Create the location list on the partition for now too, I guess. Then I actually don't need this part. Dest max, dest, yeah, okay, so those parts were for building, and this is the part that actually is the list getting set up. Now, I need to iterate my ranges. For each range, I take the target ID, and I get the jump count, and then I check to see if I can get that buffer. If it exists, I see if I'm going to need more space, and if so, I double my maximum destination, which is odd. Why am I preemptively doing that without knowing that I'm overflowing, and not doing that when I am gonna overflow? I guess that only grows once at one per step. Like, this is right before that push is going to happen, and there's only one at a time. So here's where the jump or the marker list actually happens. So that's this one. And then there's that's the new handle, and then make sticky jump destination array, and we increment that. We set the previous jump count like that. And then we have this bit here, which is about allocating and initializing the markers. It's going over the jump count. That's good. Right location, cursor, right block. Okay, what does jumping have to say about this? Name-based jump location, ID position jump location. I see, this is an ID-based jump location. Where the hell is that from? Okay. Okay, so the difference between these two is one uses positions and the other uses line columns. Line column is what we get when we parse out, and then a conversion has to be done into cursor space. So I think that this should be called an ID line column jump location, and that we will ignore that until it creates compilation errors now. And just for funsies, we'll do this as well. Okay, and then I look at the markers. I'm assuming that I will get back positions this time, not line columns, so I don't need to do any of that part, and then it fills the marker. Okay, so that's gone. Instead what I do is I begin a temp, I grab the markers array, I fill them directly from the positions of the jumps, and then I set my markers. So really, location buffer right. So this can go away. This can go away. This that can go away. Okay, so that's the version we're going to get working first. It also has a bunch of API changes, so let's get that handled. Gone. Build again. Build again. It's getting dark. Let me go turn the light on. Alright, and back to it. Renaming all the things. It's a bad habit of mine. Probably should stop doing this. I don't know why. I just always end up investing the time it takes to convert names. ID. Okay. So that's a part of this thing. Let me just remove it for a second to see if there's anything else. Is anyone else weirded out by this function? Let's track these down. Clears a 0. Checking that. Jump. Yeah, so that is a line column jump location. And then jump ID line column. Skip this jump. Where do I have jump is repeat though? So the ID position jump location, go to next filter jump, get jump from list. I'm not crazy, right? That code looks stupid. Get jump from list. Okay. ID position jump location. Location. Yeah, so that's pulling out the jump location from the buffer. Destinations. Boom, boom. Get buffer by handle. I pull out that guy's handle. I get markers. I'm getting one marker at that index there, and that's how I get that and that. And yet when I check if this jump is a repeat, I'm checking the line number of the line column versus the position of the jump location. What are you talking about? Jump is repeat. The weirdest part is that this code works. I think. Yeah, all of these things are calling it. It's used for going forward and backward. Skip repeats, skip sub errors are both the part I really don't get is when does prev location even get updated? Go to jump in order. Aha. Okay. There's something. So here we can see that, right. Okay, I don't know how we ended up in this scenario though. What is this? Advanced cursor in jump view. This is part of jumping. Do I use that anywhere? I use it in seek jump. But do I use this version anywhere is the question. Alright, we'll find out a different way. Okay, so that's all there to support the old style jumps. That's what's going on. Fine, okay. So it's correct. It's just I didn't note it is correct. And so now I will. This looks wrong, but it is correct. The prev location is a line column type because that is how the old style direct jumps worked, and they are still supported. All code paths in the sticky jump system treat line as the field for pose and ignore column. When the time comes to remove the direct jump legacy system, then when the time has passed, and the direct jump legacy system is gone, then this can be corrected. Okay. Didn't want to do that. Okay. So now we need to get init marker list working. We're going to get this version working. So this version has a few things that won't compile right now. The first of which is that. Let's go to the framework. this guy, pose jump location array. It's going to be locations count. Also, where is range? Whoa. Is it saying it can't find it? Is it a union? There's the problem. Alright, dock that later. And now oops, you come up here. What I am interested in though is having that right there. You please follow along with this while this no. I'm saying you need to follow along with this no matter what happens up here. Do not lose track of that. Okay. Perfect. So now that it can't see the new lines, I can go ahead and type up what I need to type up. So let's start with ID pose jump array, jump location array, parse buffer to jump array, and that takes a partition. Call it arena on the inside though, because I'm gonna fix that misnamer sooner or later. App and a buffer ID. And now with that, I can come down here and look at how the parse actually was done in the first place. So we're going to be outputting this. Okay, the jumps will be pointed to the beginning of the arena at the start, and then we'll get the count by subtracting wherever the arena ends up from where it started and converting that to an integer. Now we're building an array of jumps. What we want to do is iterate like so. For line equals 1, line increments, then we're going to begin temp memory on the arena, and then we're going to end temp memory on the arena, and if we output a jump, if we do output a jump, what we want to do is push an ID pose jump location onto the arena, just one, and then we're going to set its buffer ID, and we're going to set its pose, and those all need to be stored up here. Buffer ID, outpose, okay, temp. There we go. So now I have, the only task I have is I have to read this line here, and let's see, I'm gonna have to get a buffer summary for all of this to work. Buffer equals app, or get buffer by, I think it's just get buffer, app buffer ID access all. Get the buffer, and then I go, okay, what's the deal? I need this and this. Okay, so that gives me the line string, and then I'm going to try to get the colon index. That I get like soda. And so, what is this location thing? Name-based jump location. So that gives me a name-based jump location and a is sub error. And then it says output jump. So I have to do these conversions here manually. Okay. So along the way, what I then have to do is grab this. If I'm outputting this, I grab that. Now I have a buffer name, and let's see. Oh, there's a problem. The location is going to use the line string right. So we're not going to actually output jump here. What we're going to do is say great. No, we will output jump. We're going to do this actually differently. This is going to come up here and be a part of this part where we have the temp still in place so that this is still valid. And then if we get that file there, then all I have to do is say move this out here. And so now our jump buffer is one that we can grab and keep sitting around. So now we know if it's a sub error, what jump buffer to use, the jump location to use. The last thing I need to do is I need to ensure that the jump buffer exists, and then I have to do a cursor thing. So buffer seek. I'm gonna have to go to the docs here. Buffer seek buffer compute cursor. Okay. So we want to see if we can compute the cursor. Here's apps or app. Here's the jump buffer of interest. Buffer seek line car cursor partial cursor. Now buffer seek line char, I assume that that just needs our locations line and locations column, and then from there, if that succeeds, we will tell it to output the jump buffer, and we will give it these two things then. The out position is the cursor position. The out buffer ID is the jump buffer.buffer ID. And then we set out jump equals true, and there we go. So these are things we build up along the way in here. We don't need them to last forever after all, so for instance, right here we get the jump location, and that's the only scope at which we'll need that. Is sub error, I'm not sure what we'll do about you, but I'm gonna scope you for now too. And then jump buffer, we can get you right here. And so, as it all works out, this part here all happens in a temporary memory block, so that when I push this later, it will it'll be the next thing contiguously from the previous thing that got pushed here. These will be the only things that actually stay in the arena. All the memory we need for storing this out can be temporarily kept on the call stack and then pushed onto this stack here. Okay. Let's see if that is okay. Name line column jump location. What do you mean? Oh, I messed up. Okay. Well, why don't I just keep it that way? Because it's not the point. And I already spent the time to rename it once. I'll make that another pass of renaming nonsense in the future. That should say colon index. I feel like is sub error and colon index are both things I'm going to end up wishing I had, which is annoying because it means that the ID pose jump location array isn't exactly right. It's more going to be the sticky jump array, and a sticky jump will contain in a buffer ID, a position, a is sub error, and a colon index. Possibly even a line. Yeah, I can see that coming, so I'm going to change that if everything else is compiling in this function. Okay. Buffer seek line char. Seek line char. Perfect. Okay, so since everything compiles, I'm now going to sticky jump contains the following things: list line, list colon index, is sub error, buffer ID, jump buffer ID, jump position. Okay, and then we can grab that again, make an array of them, and then we can go hog wild renaming ID pose jump location to sticky jump. Okay. Now we just need to beef this up a little bit. So colon index is sub error. You guys come out here. Can live up here like that, I guess, or like this. Who knows? Really doesn't matter. And then this can be the jump buffer ID and the jump position, and the jump can also contain the list line, and it can contain the list colon index, and it can contain the is sub error. And therefore we can output all of our sticky jumps from the buffer into this array and return it. Right? No complaints? Great! So the next thing we want to do is implement this one. It's also a push an array onto an arena type. This takes the sticky jump array and, whoops, don't do that. Pushing array onto the arena. That minus result.ranges. Result.ranges equals push an array onto the arena. This time there again, and so now we just have to visit all of our jumps, and what we're going to do is we're going to say if jumps I dot buffer jump buffer ID does not equal jumps start I dot buffer ID, wait. And then what we're going to do is we're going to make a new range, push an array onto the arena. The new range will have its first at start I, and the new range will have its one past last at I plus 1. And then start I can equal I. There we go. That's the way to do it. Okay, and then this is of course if is end, and then there we go. So what's next? Right, it's a jump buffer ID. I apologize. First, you don't think range has a first. Let me see. Oh, you're right. I haven't written that version. Moppy is first, and one past last is the first value in the range. Is also the start. Is one past the last value in the range. First is also the one past last is also one less than the end. No. I'm just not even gonna unioned with min, unioned with max, unioned with min, unioned with max. Okay. Alright, I see. So you're going to get the buffer summary anyway, so why don't I have you pass the buffer summary in there, and we'll take the buffer summary right there, and there we go. Buffer ID, you mean jump buffer ID. So for each one of these things, I grab the jump buffer ID, I grab the jump position. I don't know what to do about those other things that I didn't save yet. I'll have to find a way to save them later. Scope. Right. So no scope. And you're mad because that's not the right function signature for buffer and markers, because I was considering changing the function signature. Let me back off of it for now. So there's the location buffer, which you get by going buffer summary location buffer equals get buffer app target buffer ID access all, and then I grab the jump count for that, and I'm going to put in 0, 0, and 0 for all of that. Bloop. So it's a little bit busted right now. Make Stipkey jump destination array. Ugh. 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 I don't really understand what that does. First jump index handle. I see. So is it talking about? ID based jump location. New ID equals ID based jump location. It's talking about an ID line column jump location. ID location. So that's where the search buffer thing, the jump buffer, the jump list buffer, the list buffer needs to jump to. Location count plus equals 1. And that happens every line. Okay, and this happens, okay, I see. Right. Okay, so that's how that has to happen. So basically I just need prev jump count to equal 0 when I start looping here. Each of these represents one successful parse, and so putting it side by side with that is basically the equivalent. We get the jump buffer, location buffer, okay, so we don't need both of them here because we don't need to track the previous and current since we've had the range builder already do that for us. So let's see, all of that is working. This is just the part that figures out whether to emit everything or not, and we just emit one every time without worrying about it. And we do that for each range, right? So this is per range here, this is per range here, and then down here is the per jump thing, right? And so every time our jump is successfully parsed out, we do one of these. And so that is just going to be equivalent to iterating across the jumps again and doing this. Alright, so ID based jump location, you mean ID line column jump location, I think. Push an array, one of those. New ID location. ID location. ID location. Right, okay. So location file, location stir. Yeah, all of that stuff comes directly from here now. Jump buffer. I don't get why we're using the buffer ID from the jump buffer. Okay, so that location there. We're storing a line and column for that. ID location. New ID location. Location count. So this is it keeping track of all the locations, and then later it takes all those locations right here and converts them into that. So that's the part we've already done. We don't need all this new ID location stuff. That's for doing this stuff up here that we're doing in a more simple way. The only interesting part is that we need to, for each of these things, introduce one of these. Yeah. Perfect. So if this is hit its limit, we double the max on that. And then we figure out the flags by going and looking at if it's a sub error, which we need to do by going to jumps.jumps.j plus range first is sub error. Why don't I just do j this time though, because I don't need and then that gets doubled, we figure out the flag, and we take the line jumps.jumpsj dot, and then of course I need to look at what is called list line. Okay. And then list jump count. Okay. How does that feel when you compile it? Alright, so the only thing you don't know is this handle business, but that's just the new handle that you're worried about. Buffer set markers. Yeah, you still want the buffer summary coming in there, so location buffer. Unreachable code, you say. Except I'm not sure where I'm supposed to actually break out of that loop anyway. I see. Alright, so I don't know if it works or not, but I'd be willing to guess that it probably is close, because I feel like the code turned out much simpler this time by breaking it down into like the parsing stage and then the grouping stage and then the emitting stage, rather than having them all bundled into one loop here the way it was originally written. And there's just a lot less bug-prone stuff. The end temp memory got to be simpler, so I don't have this everywhere. I have one place where I have to double up the end temp because it can happen in two places. And just besides that, this list generator for the jumps should be correct, I think. This part right here is just a straightforward range marker that I've written many times for different purposes, so I'm not too worried about that. So the only other place where things could be going wrong is if I misunderstood something in the setup for how to fill the data for the jump list structure here. But I am somewhat confident that if I do have a bug, it'll only be there and not be that hard to grok. So let's see how close I actually am. Alright, to actually test this, I need to go somewhere where I can get good compilation errors. Okay. So, what do I want now? I want to go to sticky jumps. And I want to go to this part and enable it, and then build. Alright, so it starts complaining about all kinds of stuff. Alright, well, that's working at least. But that's just one error, or errors in one file, which unfortunately does not confirm for me whether or not some of the other more complicated stuff works. For instance, if I do this and then step, alright, so that still breaks because it's expecting that these markers exist when they don't, because the buffer's been closed and the callback is gone. Sweet. Okay, so it actually is working. I could in fact make it really be working and not crashing by putting back in all the old callback stuff so that it can maintain the list the same way it always has. And now the only thing that has changed is how I'm filling that data so far, so that the data fill can be a lot simpler. Oh, whoops, I better reconfigure it to compile though. There we go. And so now, I suspect everything works again. Including the ability to sticky jump through that, kill that buffer, and then keep sticky jumping through it. Yep. Cool. Alright, so that's about as much time as I'd like to have to work today. I can do a little bit more though, because now this and this can be promoted up one level in the file so that this can start to work. And the old one can go, because even if nothing else has happened, at least I've written a better version of this that is easier to read and maintain and stuff. Okay. So, let me get the rest of this set up for what would have to happen next and see when I tap out here, which will be any minute. Any minute now I'll feel like I'm at the end, I think. Yeah. Alright, that's a new thing. This I can actually get right. Okay, so it looks like it's only complaining about the new API stuff that I want to do, which is good news, because it means that I just have to write the new API stuff that I invented, and this will start compiling again, and keep working, hopefully. Although once I switch over to this will no longer use the old data structure, which is what this one did. So basically I've confirmed that this part and this part are working correctly. The rest of this might have a bug in it, and even once I've implemented all the APIs it relies on and gotten this bug free and the APIs bug free, all the stuff that actually iterates the list is still not ready and needs attention. So it's going to be a little while, but we're getting there. We're getting there. I have to think through some stuff still, like right now I have each node containing a marker handle, but that node might also need to know things like what's the number of markers in that array right there, and like what is the it might also be useful to know stuff like what is the line number and column index for the list, so that I can set that when I do the jump too. So I think that this is actually not enough information to put into the node. That alone won't do it. And so it means I may also want to have an extended version of this that's like maybe I do managed memory alloc app scope size of a sticky jump, managed jump equals, now let's see, I presume I'm and that's got to be times the jump count, and then I can mem copy into the manage jumps from the jumps.jumps plus range.first jump count this much memory here, and then I'm closer, because now if I can bundle that information there, I mean that's not quite right. That's not really what I want either. I want the part of the sticky jump that has been transferred over to the handle. So the handle contains this and this. These three things I still want separately. So like that would actually be what goes here, and I'd need to do an iteration to fill that part, and then I still need to find a way to set all of that, the managed jumps, the marker handle, and a count into this node, right? So then it's like, what's the next step? Maybe there's another memory alloc thing that, or managed memory alloc that has the pointer to this, the plus, if I return them a real pointer that they can write into, then we're getting some kind of weird memory space that is shared between the two sides, which I guess is okay-ish. It's not an operating system after all. They just I have to count on them not to hold on to that pointer. Alternatively, what I could do is memory handle this. Right, And then, I don't know, maybe what I want to be able to do is set that a node has some variable amount of space. And so then what I could do here is we're talking about sticky jump list members, or sticky jump list coordinates, and that's these three things, or list details, or line details. And so then I'm actually getting sticky jump line details here. I'm filling the line details here, which is going to mean something like grab that, I don't know. If it just allocates a pointer and returns it to me, that wouldn't be the end of the world, I guess. It's just a little scary to think that the user will have a pointer that they need to understand that its lifetime is such that it can't be stored. I can't really... Yeah, I don't know. I don't like that. On the other hand, I don't like them having to do what I'm about to make them do either. I feel like this is the best option I've got. List line, list colon index is sub error. And then that comes from jumps dot jumps j plus range dot first list line list colon index. List is sub error, and then I want to manage memory set. Here's the memory handle, here's the offset, size of a details times j, and here's the memory, and here's the size of the memory. And so in that way I get to set all the memory bits one at a time like that. Probably what would be better though is if I could do boom, boom, boom times boom, or I could do line details mem size equals, grab all of that, and now I can just write this and this, and now I have to take a pointer to details, push array arena, one of these times this, and then details j dot those things get filled from those things, and then I can set it all at once, and then I have to, in addition to all of that, I have to wrap it in a temp. So marker temp equals begin temp memory on that partition as well, end temp memory on that marker part, marker temp. Alright, and that I'll give it a different name. Temp memory, mem temp, I don't know, details temp. Okay, so then I fill out all the details data and I pass that into my managed memory, and then so now I have a memory handle that contains all the details about line numbers, is sub error, and stuff like that. So I can query that if I can get back to that memory handle. Now the next question is what goes in there, and that could be like a struct sticky jump list node, sticky jump node header, or yeah, something like this, which would contain the memory handle, the marker handle, and a count. And so then this can go here, and the node will act kind of like memory acts, except it'll also have that right there. So then this can be managed memory set app memory app node handle 0 node header size of node header, and then I can just make one of these node header things and say that the node header memory equals that memory handle, the node header markers equals the marker handle, and the node header count equals the jump count. Okay, so this is kind of cool. Now what I might end up wanting to do is buffer set markers might want to get replaced with managed memory set as well. And so then I have this concept that there's an API called managed memory set and managed memory get. And there are different handles that have managed memory attached to them, and then those handles can have other properties. So there's the basic memory managed memory, there's the node, which can also be inserted into lists, and when it gets freed, it gets removed from the list, and these lists can be iterated. And then there's the marker type that is again just an array of integers, or an array of, yeah, I guess an array of integers or an array of markers, and it gets interpreted as an array of markers, and the thing with them, the whole gist of them, is that when you create them, you not only do you put them inside of some dynamic scope, but you also attach them to one particular buffer, which, when that buffer gets edited, moves the markers around. I think that that would be a pretty solid system. And then I just have to implement the iteration for this, and the iteration for this will basically force me to say that a marker list contains, it wouldn't need to contain any of this stuff, but it would need to contain the previous size still, and it would still need to contain the, it would now need to contain the most recently visited index, and I guess that's where things get a little bit hazy for me, which is that it's very possible that we want to store what node we were in during the iteration, and then that node just disappears underneath us. How do we recover from something like that? I'm not totally sure about that. That seems a little bit fishy still. Basically, the code you would want to write for this would be that this entire list now has the ability to be indexed, and that we can maybe keep track of what index we're on, and so that if we lose one index, we just end up in some weird place, but it's not that far off. Or maybe it can be indexed, but the nodes have some concept of their size, so that if I say I'm on index 12, that means I'm on some index between this node and that node, and like, so I have a node with an index of 5 and a node with an index of 30, and then when Yeah, if I just add to the nodes their starting index, right, then if I lose my node, I can still remember the index that I thought I was at, and I look for the closest match. Like, I look for the next thing larger, the smallest next largest node, right? By iterating from scratch, or even maybe I can have some kind of acceleration structure that's built in for this type of purpose. That's like when you create your node, you're inserting it in a particular location, and maybe you want to be able to do something like, well, how do we even know when we've lost a node is one question, right? If a node handle goes bad, how would we even know? If we were storing a node handle to begin with, that is. I mean, if we stored the index and just iterate the list every time, that would be a little bit sad that that's the best we can do. What I could do is move the sentinel through the list as I'm iterating it in some way, like have an iterator node that sits in the list and keeps track of where I am. It sounds a bit weird, but it would mean that you would always, if you lost the one you were at, like you would just have it in there and it's like, okay, the one to the right of me is the one that I believe I'm at. If that one gets deleted, then something else will be left over in the list, right? And then you could just have this sitting in the memory space of the list buffer, and it keeps a handle to its node there, and then I can have helper calls that are like an advance forward, advance backward thing, and a get next thing then becomes your get the value that my iterator is at, and my iterator is actually a node that moves through the list so that when the list gets cleared, my iterator stays in there. That would actually work pretty well. The only thing that would mess up is if you're iterating the list and you hit that node and think that it's one of the type that you've added and it's actually not. You wouldn't know. But maybe you just have to mark all of your things as being like is iterator or something like this. Alternatively, the core could predict that this is a use case and have the is iterator be a thing you could set on your node. So you could do managed list node alloc app scope 0, and then or maybe it's like -1, or like list node is iterator, something like this, managed list iterator, and that creates a new node that is skipped by the getNext function, so that your iterators could actually be all over the place and not trip over each other, and they like live there inside the list with everything else, so that when the list is modified without your knowledge, your iterators stay correct. That might be the best thing I could do. I need to add some kind of iterator, auto-managed iterator API to this thing. But that's for another time. So what I've got done today is I finished implementing this API without testing it to the best of my ability, and I started working on building up the test case and finding more variations within the API that I still need to support to really put it to use. Basically what I have so far works really well for the dynamic scope like management part, but the actually putting things in, like getting the dynamic scopes I've solved, putting things into the dynamic scope and getting things out of the dynamic scopes is still kind of too primitive, is what we've discovered. And there's a lot of interesting stuff we could do if we support lists and basic memory and turn buffer markers into a different type of managed memory. So that's all stuff to do next time. Alright folks, see you later.